For this lesson, we're going to take a look at the definition of a triangle, how to classify triangles based on their sides and angles, and also some theorems and corollaries related to triangles. First, let's begin with the definition of a triangle. A triangle is a three-sided polygon. This means that it's made up of segments, and the segments are referred to as the sides, and vertices. And the vertices, or a vertex, is where two segments intersect. These are the corners of a triangle. So let's say I draw my triangle over here, triangle ABC. A, B, and C would be the vertices of the triangle, and the sides would be segments AC, BC, and AB. If I wanted to talk about this triangle, I would call it triangle ABC, and the symbol for a triangle is a triangle. You might be confused by this word polygon. It's basically a shape with three or more sides, and the sides all have to be segments, and the sides are only connected at the vertices, or at the corners. Let's take a look at classifying triangles based on their sides. So a triangle with no sides congruent would be called scalene. A triangle with at least two sides congruent would be called isosceles. So let me get an isosceles triangle for us here. So here I would have my sides marked as congruent. And if all three sides are congruent, then we call our triangle equilateral. Equa for equal, lateral for side. Equilateral. Some textbooks will say that if there's exactly two sides congruent, it's isosceles. Our textbook says at least two sides. However, if all three sides were congruent, we'd probably call the triangle equilateral. Let's classify triangles based on their angles. If we have three, not the, but three acute angles, the triangle is called acute. So if all three angles of the triangle are less than 90 degrees, it's an acute triangle. If one of the angles is obtuse, it's called an obtuse triangle. If one angle is a 90-degree angle, it's called a right triangle. And if all three angles are congruent, it's called an equiangular triangle. Notice the name equiangular, equa for equal, and angular for angle. Now let's take a look at some theorems and corollaries related to triangles. First of all, the sum of the measures of the angles of a triangle is 180 degrees. You probably knew that fact already, and we'll be formally proving this in class tomorrow. From this particular theorem, we can derive four additional ideas, or corollaries. The first one is, if two angles of one triangle are congruent to two angles of another triangle, then the third angles are, well, let's find out here. Let's draw two triangles. So let's say, it looks like these are right triangles, that this angle and this angle are congruent. They're both 90. And let's say that these angles here at the top are congruent. Let's say that they're both 40. Well, if these two angles are 90 and these two angles are 40, that would mean that the third angle of the triangle for both of these would have to be 50. So if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. The second corollary is about equiangular triangles. So if all the angles on the triangle are equal, and we know that they have to sum to 180, that means that one individual angle would have a measure of 60 degrees. Let's take a look at corollary number 3. Corollary number 3 says that in a triangle there can be at most one right angle or obtuse angle. Let's see if that makes sense. Let's try to draw a right triangle with two right angles. Wait a minute, that's not going to work because I can't close it up to make a triangle. What about two obtuse angles? That's not going to work either. So this corollary makes sense. If we're going to have a right angle or an obtuse angle, there can only be one for it to work to be a triangle. Let's take a look at corollary 4. And to look at this corollary, let's reference the diagram that I drew up here. So we've got a right triangle, and notice our two other angles of our triangle are acute. And notice that they sum to 90. Well, if two angles sum to 90, that means they must be complementary. And that should make sense because we know all three angles of the triangle must sum to 180. Since we have a right angle of 90 here, we've already got 90. These two have to add to 90 no matter what in the right triangle. And finally, let's take a look at this one remaining theorem that talks about the measures of the exterior angles of a triangle. So let me get a triangle here. Let's get an obtuse triangle. And I'm going to extend the side of the triangle here on the left. And so now we have what's referred to as an exterior angle. This is an angle that's outside the triangle. So I'm going to label this angle, let's say X. And then we have remote interior angles. Remote means far away. Think about using the remote control for your television. You have to be, well, you're probably not right next to the TV, but the idea is that you're away from it and not next to it. This is not remote, this is adjacent. But this angle up here would be remote, so I'll label that Y. And I'm going to label this angle here Z. And for reference, let's label this angle here, well, let's see, this would be 180 minus X right here because we know that it's supplementary to this exterior angle labeled with X. So let's call this 180 minus X. Let's think about what we just learned about the sum of the angles of a triangle. We learned that the sum of the angles of a triangle is 180 degrees. So I'm going to add these three angles together and set it equal to 180 degrees. So we have 180 minus X plus Y plus Z equals 180. Let's subtract 180 from both sides and see what happens. I'd have negative X plus Y plus Z is equal to 0. And if I add X to both sides, I'll have Y plus Z is equal to X. So in other words, if I wanted to figure out how many degrees this angle was, I would just have to add the measures of angles Y and Z. So for example, if this was, let's say, 30 degrees, and this was 20 degrees, the measure of this angle here would be 50 degrees. So the exterior angle is equal to the sum of the measures of the two remote interior angles. Don't forget to do the survey at tinyurl.